So hello everyone, this is the first video of the module of capital budgeting, and in this video we're going to discuss some of the base techniques used by firms to evaluate and to rank projects. Okay? Usually firms have a limited amount of resources, which implies that they need always to select which ones are the best projects that are going to deserve their scarce capital. And I want to start this video with a very basic example. So let's say that you as an investor or as a firm have a given amount of money and you are thinking about investing this amount of money, let's say $3 million, in two projects. So the first project on the left is investing this capital in buying a new horse. Okay, so the idea here is that you're going to buy a newborn horse. You're going to train this horse, and hopefully this horse is going to be able to win several competitions, making some profit. And let's imagine that if you invest $3 million in the horse, you expect to make $3.8 million on the next 3 years. On the other hand, you can invest your $3 million in a distillery of bourbon. Okay, and let's say that for this project you have an initial investment of $3 million. You're going to receive $0.9 million 1 year from now. You're going to receive more $1 million 2 years from now, more $1 million 3 years from now, and an additional $1 million 4 years from now. Okay, and given that we are trying to understand how to rank projects for a firm or for a given investor, I'm going to ask you, how would you rank those two projects? Is there any criteria under which the first project is better than the second? And is there any investment criteria under which the second project is better than the first? So we can find criteria under which project A is better than B and under which project B is better than project A. Let's say, for example, that you are an impatient investor, so you need money in the short run, 1 year from now, for example. If you're an impatient investor and you require some short-term gain, you'll probably go for the second project. Okay? However, if you want money, you want to maximize your profits on the next 3 years, you probably want to go for the horse, because on the horse you get 3.8 million in 3 years, and in distillery you get only $2.9 million in the first 3 years. Okay, so the idea of this very basic example, I'm sorry, I just hit the microphone. The idea of this very simple example is to illustrate that ranking projects is usually a task that depends a lot on your methodology and depends on what do you want as a firm, as an investor. Okay, so today we're going to analyze a few of the possible criteria. Okay, and the set of criteria to rank project is what we call capital budgeting. Okay? So capital budgeting is a field of finance that recognizes that firms have a scarce amount of money that will have to be invested only in a few selected projects. Okay, so the scarcity of money makes the selection of the best projects a necessity for firms. Now, how to decide? That's what we are going to analyze today. Between the techniques that we are going to analyze, we can divide them in two groups. The first one is what we call cash flow based techniques, and those techniques receive this name because they are basically calculations based on the cash flow of the firms. So the only thing that we need in order to calculate which project is best under these techniques is the full cash flow of the project. Okay, so basically we need a list of all the payments that each project is gonna give in a given year or in a given month. And using this information, we'll be able to calculate which one is the best project. Okay, so we're going to analyze 3 techniques in this field. The first one is going to be the payback technique. After that, we're going to analyze the net present value technique and the internal rate of return technique. Okay, another way to calculate or to rank projects is by using other non-cash flow techniques, which are based on accounting measures. So for those techniques, we're basically going to look to the impact of a given investment in the balance sheet of the firm. And using this information, we can calculate some accounting measures. But this is what we're going to analyze in a next video, not in the current video. The first technique that we're going to analyze today is a very simple and intuitive technique. And this is called the payback technique. Okay? And basically, we're going to analyze in how long a given project is going to pay back the money you invested. Okay? So for example, if you watched Shark Tank or a similar show, one of the first questions that the investors are going to ask for the entrepreneur is for how long I'll have to wait in order to get my cash back. Okay? So that's the payback rule. And under the payback rule, the investor is going to choose the investment that has the smallest payback time. Okay? So the advantage of this technique is that it's very simple, easy to calculate. However, it's not super informative. The main problem of this technique is that if you focus only on the time that it is required for you to get your cash back, you are ignoring everything that happens after this period. Okay? And we're going to analyze some examples that illustrate why this technique is not really good sometimes. So going back to our example of the investment in the horse or the investment in the distillery, we can calculate what's going to be the payback. Okay? So the horse investment is only going to give you money after 3 years. So here, the payback, the payback here is going to be of 3 years. Okay, so now let's analyze the project of the distillery. Here, in the first year after the project, we get 0.9 million. We still didn't recover the full investment. After that, we receive one additional $1 million, so $1.9 million. We still didn't recover. After that, we get another $1 million, so $2.9 million. We still didn't recover. And finally, in the last year, we receive another $1 million, from which we get $3.9 million. So here we recover the initial investment only after 4 years, implying that the payback is 4 years. Okay? So in this example, if an investor is using the payback rule to guide his investment, he would choose the horse investment because the payback is shorter. Okay? So, again, the payback rule is attractive because it's simple to calculate, easy to understand, but it's usually not used as the main guide for investment. Okay? The technique that is more accepted as a good guideline for investment is what we call the net present value rule. Now, how do we calculate the net present value of a given project? Okay, so in order to motivate this concept, let's imagine that we have a given project requiring an initial investment of I. And let's assume that first we know what's the cash flow of this project, C. And second, let's assume that there is a same risk benchmark project with the same type of risk as the initial project, and the return of this project is going to be R. Okay? So the idea here is that I'm going to compare my investment project with this benchmark investment project. And the idea of the NPV is that my investment is only interesting if it is better than this benchmark project. Now, how can we calculate this comparison in mathematical terms? How can we do this comparison in mathematical terms? So here, let's say that I start with my investment I, and I can basically do two different things. I could invest in my main project, and if I invest in my main project, I'm going to get a cash flow of C. If I invest my money in the alternative project, so I'm going to call this alternative, in the end, I'm going to receive a return of R. So my final cash flow is going to be 1 plus R times I. Okay? Now, under which circumstance I'm going to prefer my current project over the benchmark project? So the investment makes sense. So the investment in the main project makes sense if and only if my final cash flow in the current project is larger than the cash flow in the alternative project. So this is going to happen if and only if my cash flow C is larger than 1 plus R times the initial investment. Okay. Now we can rearrange the terms in this equation and conclude that this is going to happen if and only if C over 1 plus R is larger than the initial investment. So this number, C over 1 plus R, receives a special name, and that's what we call the present value of the project. Okay? So I'm going to invest in this project if and only if the present value of the project is larger than the investment. And in order to calculate the present value, I use 1 plus R in the denominator of this fraction. And here, this term R can receive several names. Usually, we call this number R the discount rate or the cost of capital. And the basic intuition of the number R is that any investor investing in this project is going to require a return larger than R, because R is the benchmark return that they could get in this vanilla benchmark project. Okay. The idea is that this main project that is being offered should be better than the benchmark project. And another way to write this equation is by shifting the investment I here to the left side. So we can write C over 1 plus R minus the investment. This should be larger than 0. Okay? And this term in the left-hand side is what we call the net present value. As you can see, the difference between the net present value and the present value is that on the calculation of the net present value, we remove the initial investment. And that's why it receives the name net, because it's net from the initial investment. So this equation shows that investing in this project is profitable, or it makes sense if and only if the net present value, when using the return of the benchmark project as a discount rate, is positive. Okay? So in order to make this concept clear, let's work in this very simple example. So let's say that you have a project that's going to pay you $1 million in 1 year. And this requires, excuse me, this requires an investment of $850,000 right now. The cost of capital is 10%. So what's going to be the present value of this project and the net present value of this project? So let's start with the present value. So the present value of this project, by what we saw, is defined as the ratio between the cash flow in the future. So here we have 1 million. And we're going to divide 1 million by 1 plus the cost of capital. And here the cost of capital is 10%. So 10% is 0.1. Okay? So we get 1 million over 1.1. Okay? And if you do 1 million divided by 1.1, let's just do the calculation here. Oops, wrong app. So let's just open Excel here to make a very quick calculation. So I'm going to do 1 million, and I'm going to divide that by 1.1. You see? That happens when you do things live. Sometimes you don't remember the results of calculations. So this is going to be around $900,000. Okay, so this is the present value. The present value of this project, around $909,000, is larger than the initial investment, so investing in this project makes sense from the NPV perspective. And we can also finally calculate the real NPV. So here the NPV is going to be just the present value minus the initial investment of 850,000K. And according to my calculations, if I am correct, this is going to be equal to $59,000. Okay? So as you can see, both the PV and the NPV calculations are going to deliver the same answer. Not the same numerical answer, but the same recipe for the investment. According to the PV and to the NPV rules, we decide that this is an investment that makes sense. Okay, and we can extend this concept of NPV calculation to the situation where we have n future cash flow instead of just one cash flow. And the logic is very similar. So if we have n cash flows, the present value of a given investment is going to be the first cash flow C divided by 1 plus R. This is what we had before. We sum the second cash flow. And now we need to be careful because the second cash flow is going to be 2 periods from now. And given that it is 2 periods from now, we need to discount twice. And when we discount twice, we have a square. So this is going to be 1 plus R squared, and so on, until we reach the nth term. Okay? So this is the calculation of the present value of a project when we have n cash flows for n periods. And the NPV, as always, this is going to be the present value minus the initial investment. Okay? Excuse me. So for the net present value, let's now analyze a situation where we have multiple cash flows. So here we have a project that is going to pay $1 million 1 year and another additional $1 million in 2 years, requiring a investment of $250,000. The cost of capital is 10%, so let's calculate the present value and the net present value. So here the present value is going to be 1 million divided by 1 plus R plus 1 million divided by 1 plus R squared. Given that R is 10%, this is going to be 1.1 plus 1 million divided by 1.1 squared. Now, you're not required to do this type of calculation by hand. You can always use a calculator or do as I do, just go to Excel. So how could we do this calculation in Excel? So we're basically going to do 1 million divided by 1.1 plus 1 additional million divided by divided by 1.1 to the power 2 because we have the square. Okay, and this is going to be 1,735,537. So 1,735,537. Okay, and in order to calculate the NPV here, we simply subtract from the present value the initial investment. So 1,735,537 minus 850,000. Okay, and according to my calculation, this is going to be around $886,000. Okay, so this video is getting a little bit long. I'm going to stop here and I'm going to record the continuation in a second video. See you there.